Good afternoon, this is Brendan, and today I'll be observing the motion of a basketball rolling across the ground. For my lab, I filmed a standard-sized basketball, which has a diameter of 23 centimeters and is 566.99 grams, rolling across the ground like so. I then loaded the video into a tracker and tracked the motion. The first thing I had to do was set the coordinate plane, where I chose to put the plus x on the right and the plus y on top. The motion is pretty simple. It is a basketball rolling in the plus x direction, with no motion in the y or z directions. After using Tracker, I made my computer model in GlowScript. I had to change the code to make the ball the same size, and I had to change the initial velocity in the x direction by finding the average velocity from my observations. One main assumption we can make is that there is no friction, and because of this, we can assume no net force. I also had to code the graph, position versus time. This computer model shows exactly what is in the original video. With the position and time information from Tracker and GlowScript, I was able to make these graphs. The blue line is the actual observations, and the orange line is the computer model. The reason the blue line is curved, or slightly higher at the beginning and slightly lower at the end, is because friction slowed it down in the observations. But in the computer model, I ignored the friction. But they are both showing positive constant slope, meaning the velocity is constant and in the plus x direction. So what if I flip my axes? All that would happen is now my ball would roll in the negative x direction, and my graphs would have negative slopes. The last thing I want to mention is that all the forces can be added to equal 0. When the ball is rolling, after it started rolling, the force is 0. Since we are ignoring drag and friction, the force in the x direction is 0 in total. In the y direction, the gravity and the normal force cancel out, and there are no forces in the z direction. I just want to say thank you for taking the time to watch my lab.